Okay, and the equation of the tangent line that we just determined, it was negative pi x. Oh, no. Negative pi x and plus pi divided by 2. And I want to use a viewing window because x is 0.5. I want to use a window between, let's say, negative 1 and 2. Negative 1 and 2 with a scale of 1. And y minimum, negative 1 and 1 with a scale of 1. Only because I want to see how this function at that point, 0.5 comma 0, how it shows that the tangent is tangent to it. Let's double check. Look at that. At this point, 0.5 comma 0, this is the equation of the tangent to the graph of cosine pi x at 0.5 comma 0. Perfect tangent at this point. Negative pi x plus pi over 2. Good. Any questions on this? How do you feel about this topic so far? Can we continue? Okay, what I wanted to say before we continue is this. The slope of the tangent line at a point is the same with the instantaneous velocity at that point. Of course, assuming that the function is a distance function. When f of x is a distance function. Same thing. So if I determine the slope of the tangent line, or I determine the instantaneous velocity, they will be calculated in the same way, identical way. So if the problem now says that the function is a distance function, instead of asking us to find the equation of the tangent line, or basically instead of asking us to find the slope of the tangent line, they will ask us to find the instantaneous velocity at a point. Same thing. These are two identical topics. Just as we talk about the instantaneous velocity when the function is distance, and we talk about the slope of the tangent when the function is just a generic function, not a distance function. It's still both of them, both the slope of the tangent and the instantaneous velocity give us the rate, the instantaneous rate of change of a function at a point. Same thing. So in other case, let me write this down for you. In any case, the slope of the tangent line represents the instantaneous rate of change. Rate of change. Of f of x, whatever that is, with respect to, that's how lazy people write, with respect to x. In any case, the slope of the tangent line, or the instantaneous velocity, if that's what you want to say, represents the instantaneous rate of change of f of x with respect to x, which we already know is similar to, anyone?
The difference quotient.
That's it. That's what it is between P and Q, but they are so close that it's almost the instantaneous rate of change. Great. So now, that being said, we are going to ease into something very important. So when P gets closer and closer to Q, what happens to the slope of the secant line PQ? Gets closer and closer to
Does it get closer and closer to the slope of the tangent line?
awesome. And when P gets closer and closer to Q, what does really happen to H? Remember, P has coordinates x comma f of x, and Q has coordinates x plus h, f of x plus h. So when P gets closer and closer to Q, Q gets closer and closer to?
Closer to 0, but never to 0.
Excellent. Excellent. Thank you. Who said that?
Caitlin.
Thank you. Okay. Well, I don't want to erase this, but we don't really write it like this. But that's all it means. Don't erase it. Everything is perfect. Everything is correct. But we don't write this. We write this. The limit of the slope of the secant line PQ as h approaches 0 equals the slope of the tangent line at P. And now, what is this? This is the condensed, everything I said here, it's condensed in here, in mathematical terms. Let's talk about this. What is this LIM? So the limit in general, as x approaches a from f of x, this is a limit operator. Okay, what's an operator? Something that I apply to a function is an operator. Do we know operators? Many. This is an operator. Something applied to a function. Here's another operator. Something applied to a function. Here's another operator. Something applied to a function. This is something applied to a function. Of course, each operator has a different meaning. This operator will have a different meaning than these. What does this mean? Okay, it means that the function f of x, so I have to write, I'm sorry, I should have finished it. Let me write it here. Limit of f of x as x approaches a is L. It means the function f of x approaches a number, or let's assume it's a number, otherwise the limit will not exist. So the function f of x approaches this number when x gets closer and closer to a. So I'm going to move on to the next page and write it again. So limit of f of x as x approaches a is L. This means the function f of x approaches L when x approaches a. Here's a graph of something like that. Here's the scenario, illustrated with a graph. As x approaches a from either side, the function values get closer and closer to this number L. Limit exists only if L is a number. If I cannot give you L, the limit does not exist. Not plus or minus infinity. These are not numbers. There is also something called left hand and right hand limits. How do I write such a thing? The left one, limit of f of x as x approaches a, with the minus as the power, saying with numbers from the left of a, smaller than a. This is the left-hand limit. The right-hand limit will be as x approaches a with values higher than a. Now, if the limit exists, these two have to be the same. The limit from the left is L. The limit from the right is also L. But what happened in this scenario? This is function f of x. I would write the limit from the left of a is, what do you think?
Two.
Very good. And the limit as x approaches a from the right of f of x is?
5.
Very good. Finally, the limit from either side. This is from either side of f of x as x approaches a is?
At negative infinity or?
Does not exist.
Oh, the limit does not exist at all.
From either side. From the left is 2. From the right is 5. But from either side at the same time does not exist. DNE means it does not exist. I want to share my screen and let's take a look at a few graphs. What happened to my, okay, here it is. Okay, so let's take a look at this graph. If I ask what is the limit from either side of 0, what will you say? Either side of 0. As x approaches 0 from the left and 0 from the right, the function values approach.
Does not exist.
Let's look at the graph.
Infinity.
3.
Exactly 3. As
Three.
x approaches 0 from the left and 0 from the right, follow my cursor. The function values get closer and closer to 3 from the left and closer to 3 from the right. Do we all see that?
Yes.
Perfect. I'm asking now function value at 3. F of 3.
Three again?
Yes, right here. The full point. Absolutely. Who said that?
Sean.
Thank you. The limit from the right of 3. Yes, anyone?
3.
The limit from the right of 3.
4.
Exactly. When x approaches 3 from the right, follow the function. Follow the function. Where does it go? It gets closer and closer to what?
Am I
4.
supposed to read this graph like other items with an open circle meaning non-inclusive and a closed
We don't
circle
care.
included?
We are only looking at what the function values that the function approaches. The function doesn't have to be defined at that point. So as x approaches 3 from the right, the function values, I'm not saying they're equal to. I'm saying the function values approach. This is the limit concept. The function values get closer and closer to what?
4.
Perfect. The limit from the left of 3.
They get closer to 1.
Exactly. As x approaches 3 from the left, put the cursor on the function. Follow the function, follow the function, follow the function. As x gets closer and closer to 3, the function values get closer and closer to 1. Okay, another graph. Okay, at -3 from either side. At -3 from either side.
That would be 4.
Very good. 1, 2, 3, 4. As x approaches -3 from the left, and as x approaches -3 from the right, we don't care whether the function is defined here. That's not what I'm asking. We're asking to see if both sides go to the same number. And they do, so then the limit exists from either side because both sides approach the same number. I can name it. It's 4. What about the limit as x approaches 0 from either side?